All right, so first let's bring in a rectangle. So we'll go here and double click rectangle. We'll be using this component to create an XY size for the rectangle. Now, I'll make this fairly large. We could always change the size in the subdivisions, but this will help us now be able to change that original size. And so with this, let's then turn this into a surface. So let's go here to boundary surfaces, which will create a surface on the rectangle, which is the boundary. Now we can take the surfaces and divide it using surface, divide surface. Now notice that this divides it in the U and V. We can change that using a slider here. So we got 5 and 5, which is going to be the subdivisions for this design. Now later you're going to see a work session where I take a bit of a different approach, but with this one I wanted to simplify it and show you that we can do the same thing with this design. And now that we have these points, we're going to create a triangulated design. Now there are different ways to do this, but I'm going to show you using Delaunay mesh. We'll plug in the points into the point input, but this is dashed, which means that there are all individual points and it's grafted. So we'll flatten the input. And now that we flatten the input, we can use this mesh as our design. Now notice when we have these overlapping, we kind of get this weird distortion. So now that we have this mesh, we don't see the subdivisions, but we can do extract the subdivisions by going to face boundaries. And notice that now we're getting this triangulation. We can still change the subdivisions here, and the points are going to be set here. So with this boundary, we're now going to take these points and move them up. So before this, we'll move them up in the Z direction to give it a height. And this is going to be the initial height for the design. Now we can plug the ones that we brought up to the top here. And now we've got some space for people to walk around below this. So what we need to do next is take all of these points. So I have this previewed so you can see what the design is going to look like. But what we're going to do is take these points and move them up randomly. So we'll go here to move these points up again, but this time we're going to use the component called random to move all of these points randomly up and then connect it with this mesh. So now that we have this component, here's what we need: a range, a number, and a seed. The range is going to be between what numbers, the number is going to be how many points we have, and the seed are more random solutions to the random numbers. So here we're going to go to construct domain. And this will let us pick a smallest and largest number. So we'll go here and bring in a slider of, let's say, 120, create 2 of them, set one to be lower. This is going to be, it could even be 0. And the max is going to be 120, which will give us that range that we want. Now the number is going to be how many. So here we know that we have 30 different points, and the way to extract how many we have is going to be using list length. When we plug the points into list length or any component that has objects, you're going to see that when you flatten the input, you're going to get how many objects we have. So we have 30, and so we can use this. Since the wire is kind of overlapping with things, I do tend to hide it, the input, and then we can use this length as the number. Now the seed is going to be random solutions. So we'll go here to a slider of 3. I'll bring it down to 0. And then now when we look at the output, we have 30 different numbers between 0 and 120. The first one being 87, 98, 92. And if we want these numbers to be whole numbers, we can go here to integer numbers. And now we have 87, 98. We can always decrease this to have, let's say, a max of 50. And now the output is going to be between 0 and 50, 36, 41, 38. Now we can use this to move it up randomly, because now we have 30 different numbers that are all randomly between this range, and we can bring it up in the Z direction. Now notice that this is dashed, and this one are 30 of them in a flattened list. So now we need to flatten the input. And notice that it brings them up randomly between that range, and we can change this seed to create more or different solutions to create random numbers between 0 and 50. And we can always increase this as well and then change that. So with that being said, let's go back to 50 and move the points that we plug into the mesh in. We can also disable the preview on the mesh and create a surface at those boundaries, because when you create a triangle, you create a plane. And so now we can use boundary surfaces to create a NURBS surface right at those edges. So this is useful because we can now, with these surfaces and these boundaries, develop the design here. So if you have any questions here, let me know. I think this is a pretty cool exercise that you can apply to other designs. So let's move into the next portion, which is creating the beam system that's going to go on the outside. All right, so now when we look at this surface and we hover over the output, we have 40 different triangles, and we can change the subdivisions here if we wanted to. So let's keep it simple here, 3 and 3. Then we can even change the height here if we want to. But let's keep it, let's say, at 60. Now here what we're going to do is join all of these surfaces together, because right now they're separate. We have 18 separate triangles. Let's join it using brep join. Now when we look at the output, we have one open brep, which means that when you bake this is going to be its own surface that's all put together, but we still have the creases. And one of the things that I like to do is, once we have this joined together, we can extract the edges here. So I'll go to brep edges, and we can extract the naked edges, which are the ones on the outside, and the interior ones, which are the ones on the inside. So this is going to be useful for this exercise because we can take the ones on the outside, which we have 12. We can use those and join them together. And notice that we're just picking the ones on the outside. When we look at the hover over the output, we'll see that we have one polyline. And what we're going to do is offset that to the outside. So we'll go to offset curve. And notice that this is giving us a problem because it can't tell how to offset it. So we actually need to bring in an XY plane and plug that into the input here. So now it's offsetting relative to the ground plane or the XY plane, and we can pick a specific number for that. So we'll go to 15.00 and use this as the distance. Now let's create a surface between the two. So we'll loft together the outside or the inside one, and then the one that we offset to the outside. Notice it's not working, and that's because we need to flatten the input. So now we've created this small surface between those two, and we can now take that and extrude it down. Now let's see if we can clean this up a little bit using merge faces. It's not necessarily going to do anything much, but now with this, let's extrude this down. So we'll take this loft, extrude it in the Z direction, so up or down, but we want to extrude this down. So in the negative direction. And now we can use a slider to extrude this down. I'll copy the slider, bring it over, tap Alt, plug this in. And now we've created the outside fascia or the outside beam that's going to kind of contain the entire design. Now then we can shift this up and down to kind of hide some of the beams if we need to, but for now I think this is going to serve us well. Let's move this up a little bit more, the original one, the original height. And now let's go back to our edges here, the interior ones, and we're going to now extrude those down. So rather than just creating a whole new, set of components, we can just take this extrusion that has been extruded down for the loft and just copy it and overwrite it with the interior lines. And I'll use this one to kind of create the depth of it. So we'll go to 16 for that. And so these are going to be like the beams or the structure that's going to hold up the other frames. So what we can do here is take each one of these and offset it and extrude it. So what I'll do here is select just one to show you how that we can extract just one of these, and what we do to one, it can do to all of them. So let's go to list item, plug all of those into it. Now we'll be just using and developing this one. Now we'll take this line segment or that surface and offset the surface. It's going to offset perpendicular to that surface, so we'll go here to 1.5. And then we'll do that again. So this one will be 1.5 to one side, and if we use a negative component, this will offset to the inside, or to the opposite side, by 1.5. So now we can take these two and loft them together. Notice that it creates the ribbon all the way around. Now we can join using brep join the two outside ones and that ribbon that is lofted in between. When we look at the output, it says one closed brep, which means that now we can use this as our beam. So since we did that to one of these surfaces, we want to be able to do that to all of them. So this means that this is a flattened list, which means that it's only going to pick one. But if we graft the input, it will do it to all of them. So we've created this beam system here, but notice that when we offset to one side by 1.6 and to the other side by 1.6, we actually need to divide this by 2, because 1.6 and 1.6, if we divide it, make it 2. If we do 2 here and 2 here, this is technically 4, and so this won't be the actual value of how thick this is unless we divide it by 2, because then if we do 2 divided by 2, which will equal 1, it'll be 1 this way, and therefore the overall is going to be 2. So that makes it so that this slider is a true number that we have for this system. And the cool thing is that we can go back and add, let's say, more divisions. And all of those will do the exact same thing. So let's disable the preview on and keep this organized. And I'll disable the preview on all of these. And this. So then now we can move on to the next part, which is creating the inside frame. So when we go back here and we look at the boundary surfaces that we created, or the boundary of the mesh, now we need to offset this boundary to create an additional frame. It's going to, by itself, offset to the outside, so we know we need to bring a negative value and offset this to the inside by, let's say, 1.5. And so if we look at the beam and we know that this beam changes and this beam is going to be 4, well, we know we need to offset this frame by half of that. So we'll use this half value, plug it in here, and it will now go to the exact boundary of where that beam is. So now we don't need to use a different slider. We'll just use this one because if we increase this one, then the offset for the frame will also change. And it'll be exactly to that size. So now we're going to take that and offset it one more time to the inside, but this time we will use a slider. So I'll use this because we already have an offset and a negative. And now I'll use a different value. We'll say 1.5 and use 2 decimal points to offset this to the inside. And now between these two, I'll create a boundary surface. But notice they're overlapping. So on this one, I'll bring in a graphed tree, plug this into the input, and then use this and this one. And notice that now they're organized correctly to create this inside frame that's going to be used to hold the outside glass. So we'll take this, and notice that this has some sharp edges here. We can kind of clean it up a little bit or add another modification, which would be a fillet edges, and then use a radius here and override this input with this one. So now this is going to be to modify some of those triangles, and we can disable the preview on all of this stuff. And then we can now take these surfaces and extrude them down. So rather than creating a slider again and the extrude and all of this, I'm just going to go back here and use this to extrude it down. So notice that I copy a lot of sliders and a lot of components, because once you've created one step, then you can use it again, as long as that's what you're trying to do. So here we have this component, we have extrude in the Z direction down by 16, but now we need to preview this and then bring this a little bit up so it's not as deep as the columns here, or as the beams. And now what we're going to do is create the glass that goes on top of all of this. So by going back, so we can use any part of the script at any stage of our design and go back to it. So what I'm doing is going back to these and I'm offsetting them again. This time we'll offset in the negative direction. We'll give it a value. We'll just say like, 1.5 with some decimals. I'll also use a fillet and a boundary surface and extrude it, but this time it's going to be extruded up. So I'll copy all of this, bring this up here, use this as the input. This as the fillet. This one's going to be the input for this one. So the surface is going to be this line segment, going to be turned into a surface. Now, first, it's going to be using the fillet to round the edges, and then turning it into a surface, then extruding it not down, but up. So I'll override the negative. Now let's decrease that number because the glass is going to be, let's say, 1 inch. Now notice here that a lot of the surfaces that we've developed here are going to start overlapping. And so it gets a little bit tricky to see all the information. So this is where I'll start adding some color to it so we can see it a little bit better. Let's go back to this one, create a custom preview. We'll use some material of a color swatch. So bring this in. I like to use a bit of a gray here. We'll make it 80. And then this one will be plugged in. Now, I do like to hide the input, so a wire display hidden for the geometry for the custom preview. So then so it doesn't overlap, it's going to be kind of far here. So let's now plug this one in. You can also change the color of this one. Now the next frame, copy this. And for the glass, which is going to be here, let me show you what I do with the custom preview. Copy it here, use this, and make it blue. And then use the opacity and make it 100 here. But what happens is when you do that here, you have to disable the preview on the original. And notice that where the glass overlaps with the frame and with the beam system, we're having some issues. So this is where I would actually take the glass and bring it up, and also the frame, and shift it up. So do that here. First with the glass. So at any point we can add more modifications. In this one, we're going to move the glass up using move. The direction is going to be up in the Z direction. And the number is going to be, let's say, 1.5. So it doesn't overlap with that beam. Do you see that? Now, obviously, we need to override this again. so we can see at what point it intersects with it and we can be past it. So let's say if it's 1.5 here, well, we know we need to do that as well to the frame here. So I'll take this modification of moving it up by this much, and I'll copy it over there. But I'm actually going to undo that. But I'm actually not going to copy the slider because I want to share that slider with the frame. So if I just take this, tap Alt, it will keep this one plugged into the copy. And now we don't necessarily have to change that or create or retie it again or create a different one. It's just going to move it up by the exact same amount, and we can override this. Here's the other thing. Notice that this glass is sitting right on top, which means that it's going to give us that distortion. Let's move it up again. So if we moved it up by 1.5, we'll do 1.5 plus, and this is a way to use the addition here, 1.5 plus 0.5 to move the glass up by either, if you put it at 0, it's going to be at the exact same location. If you do 0.5, it's going to offset it by 0.5, which then we can create a connection here between the frame and the glass to connect it. So that's another thing that we could do. But on this one, we'll keep it simple. I just want to show you how to create this triangulated design. And the cool thing is that we can go back here, and if we don't like the way that this one's sitting, we can have different random solutions to that until we find one that we like, or even change the maximum. So if we said 0, 0 is going to keep it flat like that. And if we start increasing it, it's going to change that range. We can also do the opposite. Now for this next part, we need to create the columns that are going to be supporting this. So there are different ways we could do this, but what I'm going to show you is how to extract, let's say, this panel, and some other panels, whichever ones we pick, to be able to support this. So I'll change this back to 3 and 3 so we can keep it a little bit more simple. And now let's go back to here, boundary surfaces. And I'm going to disable the preview on the rest of the stuff because we're going to now develop the columns using just these surfaces. So first we need to know which ones we're going to pick. So for that, we need to first know which ones, how they are organized. So let's show you this. We're going to move this down because now we need to get the center point of these. So I'll bring in an area component. With the area component, we'll get the midpoint of each surface. Now with those centroids, we're going to bring in a component called point list, which will tell us how this is organized. Now sometimes the numbers are a little small, so I'll change the size by either right-clicking and changing the number for the size. We'll just go here to 5. Still small. Make it 15. Okay. So now we know this is 0, 1, 2, 3, 4, 5, and so on. So we can now pick specifically which one of those we want. So I'll go here to item or list item, plug those surfaces into the list. Now by default, it's going to be 0, but we can create a slider Just go here to 30. And start by creating one of the items being 0. We'll copy this. The next one, I'll hold down shift and add another input. Next one's going to be 4. The next one is going to be 13. So hold down shift and add it in here. And then lastly, we'll do 17. So we'll use the edge triangles for us to create the columns. And this is how we can, by knowing how things are organized, pick exactly which item we want to use. Because by default, when you select this, all of them are going to be in here. And to be able to select them, you use list item and point list to know how they're organized. And we could have also cycled through them using a slider, but that's not as comprehensive or easy to see how things are organized than just using a point list. So let's disable the preview on this because we don't need that anymore, but we can always bring it back. And with this, now we're going to do something similar to what we did here, where if we do it to 1, it'll do it to all of them. So now that we have these items, I'm going to now type in list item because technically in here we have 4 different ones. So if I plug this into this one, now I'm going to just be doing it to 1 and I can hide everything else. So notice that even though we have a script all created here, what I do is I hide the things that I've already developed, and then I focus on the things that I want to create. So then when I bring everything back, everything is working together. And we can also focus on the important portions. So here we have this triangle. This triangle is composed of points, a surface, and some edges. So we'll deconstruct this brep. Now notice the vertices are going to be the points, the edges are going to be these, and there's going to be a surface in the middle. Vertices, we will now bring in a component called average. And when we plug those vertices into the input, we're going to get the midpoint of the average of those points. Then what we could do is take that point and move it down. So move this down in the negative direction, negative z direction. And I'll use a slider here of 60 or so. And now connect those vertices to this point. So to do that, we'll go and use a line segment between the vertices and this point. And now we're going to project this point down to the ground. So for that, we'll use project point. The direction is going to be z down in the z direction. So I'm going to copy this and unplug that because this will tell this component to project it to the ground. And now the geometry is going to be where? Well, we know that we have this original surface that has been turned into a surface here. So we can project it down to that. And since we projected this point down to that, then we can create a line segment between the two. So use a line between start and this endpoint. The last thing we're going to need is to take these points and these vertices and be able to move them down, because some of the columns, if we bring some of this back, are going to be a little bit lower. So we want to be able to lower this. Now undo that. All right, so let's take these vertices. I created this relay because these go to different inputs. So I'm going to now move these vertices in the negative Z direction. And use a number here, let's say 1.5, and then be able to change this. So all we need to do is override this input. And now we can shift that up and down. Now I do like to, when you see a wire going this far, I do like to hide it so it doesn't overlap with all the stuff. And you can always select the component and see exactly where it goes into. So with these, we have our own individual line segments that we can plug into this component called multi-pipe. We can also use a regular pipe segment, but this one actually gives us a clean connection here. And let's change that size. So we'll go 1.500 and use the strut size. Change. Notice we get like a pinched connection here. So we're going to now use two different sliders to change the end offset and the node size. So now we can dial this one back a little bit. And one of the other things that's going to make it look cleaner is the end caps. There are different options. You can do round, flat. I'm going to use round on this one. So now let's move some of these sliders so you can see what we did here is first is being able to shift the top points. Then on this one, where the connection happens. So it can be up higher, lower, using this one. And then this one is going to change the size of the strut. This one is going to change the connection. And so will this one. And we can pick the correct size according to the scale of your design. So now here, what we need to do is, since we just did it to one, we'll right click here and go to graft. And now I will do it to all the other items that we picked, which are going to be these triangles. And here, let's change the maximum range for this slider. We'll go here to 20. Actually, no, let's make it 30. And now we can change that location here. Why? Because we're going to now bring back the entire design, and you're going to see that we can make sure that it doesn't overlap with the original structure here. So we'll select the custom previews. Bring this back. And notice that the outside structure needs to be larger so it doesn't overlap with some of those columns. So we'll do that. We'll go back to this offset. This one. And if you feel like the span is too large and you need to have a column in between, we can always go back to this. we can say, oh, I want to add an additional one for 7. And then we can bring this over. I do like to keep them, you know, organized like this. This one's going to be 7. And holding down Shift, I can add another input, and it will create it exactly at that location. Now let's take a custom preview, copy it down here, and use this to color the new columns. This is still, we still need to shift this down here. But that's going to conclude the tutorial here. I wanted to show you all of the steps that create the design you're going to see a little bit later. That's going to be a work session where I develop it using a few different steps, but for the most part, it's going to be the same idea here, where you can develop a surface into a triangulated subdivision, move it up randomly, be able to develop the panels, then pick which ones are going to be supported using the columns. So if you have any questions, you can download this on my website, capettidavid.com, for free, and you can see exactly how it was plugged in. Otherwise, let me know in the comments below if you got stuck somewhere. I want to make sure to, answer any questions that you may have.